So today we're going to talk about Android malware detection, and specifically an app we've constructed called Melvin. There's a whole lot of stories you could probably ask, like where Melvin came from, but there's our agenda for the day. We'll give you some motivation as to why we went down this path, and then Reva's going to talk about how we actually do on-device malware detection. And then Dav is going to talk about the construction of the app itself and some challenges we face there. And then we're going to help explain how folks can help us out testing this and helping us decide, do we want to put this out publicly on the Play Store? And then we'll take questions. You can ask questions whenever you feel like it as well. So I'm going to start us off talking about why did we do this? And since I've been here for about 4 years, this graph sort of summarizes the concerns I've had, and I'm not alone in this regard. This is one of many different views you could put as to what is the canvas upon which all things cyber or malware happen. And there was a point in time when PE files and Windows operating systems were where everything was happening, and I'm guilty of. In about 2006 or 2007 in my career, I went on the record saying we need to be really afraid of iOS and Android, and I was not well listened to at that point, but I keep beating that drum anyway. The question mark up here, this is only 2011. We're already kind of here. There will be well more internet connected devices than humans if we're not already there. We're right at that tipping point, and these are not Windows computers. So, and there's a general motivation that we want to take all the things we know how to do in one domain and try to work them into new domains. And Android mobile, this is sort of low-hanging fruit. Everybody's heard of it. It's not terribly hard for us to get into. So, let's go there. So, does anybody have any questions on that, or you see what I'm getting at? That's. Secondly, we need data. If we want to do this, if we want to seriously talk about being in the mobile environment, we need data. We need malware samples. Everything we do, every form of analysis we do starts with data. We have many conversations I've been through here about buying data feeds. Is our data old? Is our data new? CyberPoint Labs has been involved in various forms of data science and machine learning, and step one is always where's your data coming from? How do you get more of it? And to be honest, a big part of what Melvin was about enhancing DarkPoint. We have a malware analysis system called CyberPoint, DarkPoint, and I think that's its current name. And in one context you use it, and it's a web interface. And again, your PC, and you upload malware. But it also works as well if you upload samples from other sources. So Melvin, among other things, is a source of ingest into DarkPoint. For now, that's what it is. You can imagine in the future we could more tightly couple a mobile device with DarkPoint, and then ask more detailed questions about why is this thing bad, or what happens if I were to run it, that sort of thing. Another big theme everybody who's worked on this can speak to is inertia. It's really hard getting to here. I'm super happy for the team and for us as a company that we've got. Whatever you're about to see today, however complete or incomplete it may be, I think this is a pretty big step. Going from nothing to something is always hard. Mobile is new. We've got a few of us who've done some mobile stuff. We have a lot of related capabilities. We have experience in different languages and different platforms, but we can't, at large, respond to a proposal and say, hey, CyberPoint has 10 years of mobile analytics or malware detection, that sort of thing. So it's new for us. What you're about to see today is not done. It's an initial operating capability. It's a complete thing you can use, but if we've done our job right, it'll immediately start making you ask questions like, ooh, couldn't you also do this, or couldn't you also do that? What we tried to do is get this technology to a point where it runs on your phone, you can see it, and we can interact with DarkPoint and think about the other things we could do. I guess lastly, we're at a point in time right now that the end result of this tech talk will be an open QA period for the app. We're not going to do, there is no Melvin team. There actually never has ever been a full-time Melvin team. The folks that you'll see referenced in the talk today, everybody did this in addition to their day job. So there's no ongoing development, there's no new features being added. We just want to get this to a point into an internal test phase where we'll go into more of this later, but we'll be able to test it ourselves, look at it and say, hey, is this complete enough that we would be, as a company, this is something we want to put out to the public to look at. So with that, I think, that's the point I wanted to make. Like I said, we could not have done this if we'd waited for a team or a requirements document or a bunch of other things to happen. None of what you were seeing would have happened. The design team, super thankful. The UI elements, the user interaction, some funny conversations, some good interaction, but they were, Peter and John and Katie were a huge part of us getting this together. And again, it's new. It's not a web app. Well, it kind of is, but this is not a web app the way you think about it. And I think the funniest conversation I'll point out is somebody at one point asked me, well, like, what about a user guide? And seriously, what's the last mobile app? It's just a whole different way of thinking. When's the last time you downloaded a mobile app and said, well, where's the printed user guide for iTunes? It's not acceptable. So I can't overstate the importance of, I'm sure you guys will find flaws in how we implemented it, but a lot of work went into what you see. So yeah, thankful to all the folks who helped out. So I will now hand it off to Reva, who will tell you the mathy parts.
I won't bore you with too much math.
You said okay.
Yeah. Oh, can you go back? I just want to give a little introduction before that. So the question is, how do we go about detecting Android malware? And traditionally, I'm sure you all know, malware has been detected using signatures, which is a very painstaking and painful process where kind of for each existing sample of malware, you look at it and you extract some details of it so you recognize it next time you see it. And not only is that painful in terms of human effort, but it's very painful when that new piece of malware comes out that you've never seen before and you can't detect it. So the approach here was, can we use machine learning to find general properties that distinguish Android malware from benign Android apps? Okay. So this is sort of the classic problem in machine learning, the classification prediction problem. And formally, what that means is you have some set of data where you already know the labels. In this case, the labels are malware or not. And you want to use that data in order to create a function or a model that, given a new piece of software, a new binary, a new APK file, you want to be able to predict, is it malware or is it not? And to do that, we take these APK files and turn them into basically a set of numbers, a feature vector, where each feature might be something like, how big is the file? Does it use this permission? Does it use that permission? What versions of the SDK does it support? And so on. And so how do we do this? It's just math. And a lot of times it's ugly, painful math. But in this case, so decision trees are a particular type of model used in machine learning. And they are very user-friendly in that you will look at this and say, well, I could solve a problem like that. This is very much how a human thinks about things. And it's also useful when you develop a model like this. You can look at it and sort of understand what it is that makes your model tick. So just as a decision tree you would see in any other area of the universe, you have a bunch of nodes, and at each node you ask a question about one of the features. And the question is as simple as, is it less than some value? And if it's less, you go to the left. And if it's no, you go to the right, and so on. And then when you get to the bottom, every sample that reaches that node gets assigned a label according to which node, which leaf node it ends up on. And the process of turning your existing data set into one of these models is called training the model. And how that's done with decision trees is typically very greedy and from top to bottom. So you take all your samples, and for each feature and for each possible value of that feature, you look, is this a good split point? If I separate my data according to whether this feature is less than this value, do I get a good separation of the data in terms of getting the malware to one side and the benignware to the other side? And then how do you decide which of those splits is actually best? So you want to measure how well you're separating your malware from your benignware. And there are a bunch of mathy ways to do that. So there are, of course, some limitations of this. It is maybe a little too simple. And it's obviously not good for all problems. And there's also the risk of overfitting. Are you learning the truth of what differentiates malware from benignware, or are you learning the noise that's in your data set, or the very, very specific details of your data set? And so now we can do a little more math and avoid some of those pitfalls. So boosting is a way to take a weak classifier, which is a classifier that's just a little tiny bit better than guessing, and to turn that into a strong classifier that's kind of almost as good as possible. And the way that's done is you start by training one of these classifiers. So in this case, I'm boosting decision trees, so I'm going to be combining decision trees. So you start with one, and you look at how well does that one do, and you take the samples that it didn't do well on, and you emphasize those when you train the next one. And you keep doing this, and then you combine these in the end to get a stronger classifier. And you lose some of your intuition now when you've got this massive pool of decision trees. But you can still gain a lot of insight by looking at which ones are weighted most strongly. So I think basically it's a set of ugly, nasty formulas of how you weight your data. So initially, all the samples are weighted evenly. And then at each stage, you look at the previous classifier and weight the samples according to which ones were incorrectly classified by that. And some ugly numbers with logs and exponentials that basically come down to doing regression to kind of minimize the error of the ultimate classifier. So, so how did this work out for us? So in terms of methodology, we had a pretty small training set that we used of 448 samples, and that was limited only by the amount of benignware that we had. We had plenty of malware, but we did want to balance that because you don't want to give your classifier 1 million malware samples and just a few benign samples, because then the best thing it can do is just say malware all the time, classify everything as malware. So we did try to get that balance, and we also reserve a test set of 226 samples so that we can see how does our classifier perform on data that it's never seen before. Now at this point, our features are very simple. Didn't spend a whole lot of time trying to figure out what can we do that's fancy. We kind of went with the most basic approach. So there is a lot of room for improvement. Currently, the best model that we have used decision trees of depth 3. So when you see those nodes, 1, 2, 3 layers of nodes, and we did 16 rounds of boosting, gave us the best classifier. So on that test set that we reserved, our accuracy was 98.4%. We had 2 false positives and 2 false negatives. And then there's all that other malware that we didn't include in our training set or a test set because there was just so much of it. And we did really well at identifying 98.7% of that as malware. So that's pretty good. And this graph shows we're just a tad below the industry average, although the data that they used versus the data we used is not exactly the same. So this probably wouldn't stand up in court, but as a general idea, we're doing pretty well.
Will you say which features you actually found to be most useful?
Well, ironically, so in our initial take on this, the best feature was the target SDK version and the minimum SDK version. And then we realized it was because all of our malware was from 2011 and all of our benign samples were quite current. So I removed those features, and now I'm sorry I didn't include a slide on that because it's pretty interesting. The main thing we were looking at is permissions. What permissions does the application use?
And they weren't so logical as to which ones. It was just sometimes random combinations were, you know.
Yeah, so I showed David what it was using, and yeah, his take on it was, oh, that's not what I would have guessed. Yeah. Yeah. So I think that's all I have to say about that. Any other questions?
Oh, I had one question on the boosting. So when you say 16 boosting iterations, does it mean you wind up with 16?
16 decision trees
Do you
that
ever
are.
throw one out because the weight's below some threshold, or you always roll?
No, the idea is to stop when it doesn't give you any more improvement, or worse, that it starts making your classifier worse because you're overfitting.
Like you use everything you found at that point.
Yeah.
How does the performance go as you add trees?
Typically, you'll find it just gets better and better.
No, but I mean, is there a runtime cost on actual?
Oh, a runtime cost? Well, so the runtime cost is mostly in training. The training takes a while, but when you actually apply the classifier, you're just running through that decision tree, which is very few steps. So unless you were doing millions of them, you're not going to notice the difference.
It's a fraction of a second. I mean, it's...
There you go.
Okay. So I was handling the overall engineering of the application. Most of my experience in Android was actually doing what are called hybrid apps. I was basically, before I did anything with Android, I did a lot of web applications, and I was very familiar with making single-page applications, and which are heavy JavaScript-based applications that have a lot of logic living in the browser that are stateful, and basically they use the backend for, it can be as minimal as just data persistence, but can be a lot more. I developed applications that really used, most of the UI was in the front end and the back end was very minimal. For what we needed, really most of the logic is really in the back end doing the engine that actually does the scanning, and I just wanted to provide a simple way of presenting the data to the user. Most of the complications that we actually had, you might have thought were in using this hybrid technology, but that was not the case at all. So let me just tell you what the differences are. A native app is the kind of thing that, except for the initial version of iOS, all Android and iOS, they all have SDKs, and you can develop against the standard SDK of that operating system, and those are most of the applications that you probably use on your devices. A web app is the opposite entirely, where you would almost access, if not the files being actually pointed to that almost everything would be on a server, or you may have some static files that when you actually run them, they automatically are talking to a backend in a remote host. But the point is that there's the majority of the backend logic is on a remote device. Hybrid apps try to separate that logic and really provide the newest thing, and they basically provide a way, if you see there's embedded web views, and that basically takes whatever the device has as its browser. So in more recent Android devices, that would be the Chrome as opposed to the Android web view. And it basically puts an embedded version of that browser inside of the application, and you can essentially do anything you want in JavaScript there, but you have some added bonuses because you can have certain things are exposed. And essentially, depending on whatever you want to expose on the Java or the native layer, you can essentially expose everything that you can do in the back end on the front end. And the reason why many applications, especially the applications I've done in the past, were for a lot of economical reasons. If you want to be able to make an application that works for iOS and Android and a multitude of platforms, you could develop one front end that talks in a standard API, and then you have backends that fit Android, iOS, and whatnot, which wasn't our case, but it does provide some simplicity in that development process. Obviously, the limitations are if you have high-end graphics and multimedia, you're not going to want to do that. You're going to want to do something that's native because there's tremendous performance boosts. Okay, thank you. So why did we choose a hybrid app? Mostly because I'm not a designer, and we wanted it to look nice, and I could have made it work in the regular Android application, but happens to be the Android application the design is much more limited. It's fine in its capacity, but it has layouts, and it's very it's very directly connected to the actual application in the back end. It's like an MVVM or an MVC. There are different terminologies in the industry, but it's very tied into the application as opposed to using some sort of system where you're really using a bunch of API calls and it's a lot more agnostic as opposed to having a lot more direct connection. And Riva was handling had built most of the application already, and I came in to really just make this front end facade as opposed to having to instruct every little bit together, even though we kind of ended up having to do that. So it allowed also, John Iben and Katie to help out with actually doing the design because they have familiarity with HTML and CSS, and that's the major components that you use for visually handling web applications. So the major thing that you use within a hybrid application is usually called PhoneGap. They open sourced it it's called Apache Cordova. In short, it really is nothing more than the embedded web view that has a bunch of wrappers on top, but they do make it very easy. They have some scripts that can do starter projects, and they also have a bunch of plugins that are made. And really, for many applications, you end up just using plugins. Like if you want to do native notifications and things like that, you would really just use a JavaScript plugin that does it. And the back-end functionality is right. You have one that supports iOS and Android, and your front end doesn't change. And really, your logic is all in the front end components. We didn't do any of that because it wasn't really necessary. The major thing that the major limitation that we had, I think that's the next slide, was that, so there's a one-to-one relationship between the UI making requests to the Android backend. So when we ask for what are the list of apps to scan, that would be a request. Initiate scan, stop a scan, update preferences, things of that nature, those are usually one-to-one requests. However, we ended up having issues with the fact that that Cordova really only supports based off, it does these listeners that basically it's a one-to-one relationship. I can make a call and it can respond back, and as it may be familiar with in web development, it's called polling, or there are different terminologies with Ajax, but the idea is you'd essentially have to keep on asking every single few seconds if you wanted to get a response, as opposed to the more common terminology of push notifications, being able to push from the back end to the front. So I've actually had that issue before, and so I figured out my own way of handling it so that the back end could actually, instead of the UI having to always ask to make requests, but also that the back end could push updates as things change to the front end accordingly. Right. So the only last thing is that was all that. The only thing you needed to do for that was the Java backend, the web view, actually has the capacity to inject JavaScript directly into that web view. So all you needed to do in order to be able to push that was by having some sort of function that you invoke, and you just push your data in, and you already have an agreement as to how that callback is going to be called asynchronously, and it's quite easy if you know where to look. Okay, so the major issues we had with Android. Android is, great, but everything has its limitations, and there were certain things that were difficult and require, as Mike said, we were doing this this was only a small part of our day, so we weren't necessarily looking to do a number of extra steps, but it seemed like certain things we really had to. One of the major issues that we had was Android has things called activities, services, and intents. There are a lot of other abstractions, but activities are the basic components of the application that you start up, like from when you start an application, usually that's an activity. A service is a background process that runs and will not be killed off due to memory management, as opposed to an activity which will be killed off. So you may have issues with, there are only certain things you can tie into activities. For instance, the way that we handle being able to listen for, when you install applications, you subscribe to intents, which are basically saying, hey Android, I want to listen for applications being installed, or I want to listen for when an application is going to be reinstalled. And that's written in your manifest or in your activity, you make a you can make a receiver that you say, I want to listen for certain intents. And that can only be done on an activity. The problem is you can't then, we want to then process that and run our scans. You can't do long processing on an activity because the activity is the main thread that the major application runs. So you have to run another thread for a service. The problem is the service you can't be subscribing to intents, only activities can. And the problem, and intents only, there are things called intent services, which you'd make that are singletons. Basically, you'd start one for handling each intent. But what would happen is if something got killed in between, you lost that queue. And you didn't get them back. So there's ideas of like on destroys and on creates and destructors and whatnot that you'd be able to save things to a persistent layer. But if you just use Android's mechanism of persistence, that it would only do the current item that's in queue, but not several items that are queued up. So honestly, I didn't handle all that, but I guided Riva as much as I could in those steps. The thing that was the simplest, which I was mostly concerned about, was getting the data from the UI, from the back end to the UI, because that's actually the history section, which you'll see eventually, which basically shows the list of scans that we have. We're actually persisting that in the front end. We're using local storage with HTML5 local storage, which actually is tied into a database. It's not like just some UI thing. It's actually tied into a back end database. But I was concerned that in between the process, you would lose data. So I made sure that we had acts, basically acknowledging each time that unless I acknowledged it, it would be the UI acknowledged it. It would be constantly resent again and again. But we had issues basically in between activities, services, and whatnot. We essentially had to. What I was saying, we basically needed AMQP. We need some sort of persistent store if it was going to be a SQLite database or something like that. And like Riva said, no, we don't. Do we really need that? We don't. So what we ended up using, which really does work, is we were using these shared preferences, which is really just a key value store that's made for for your own application, or can be public shared. And really, these things are not large in data. We were serializing them and deserializing them and checking for different keys, which is a simple makeshift. It worked, but it wasn't elegant. And I was convinced that maybe there's something more in Android, but as far as I'm aware, these are you have to use SQL, or you have to set up other databases in order to handle that communication among the application. So those are the major issues that we ran into, and the other things we had issues with were fact is the one advantage I think Android has over iOS is it's positive, its pro is its con is there are so many devices. So you can't just test one of them. You literally have, Mike had that, we're going to deal with that in a moment, but even within our own devices, there would be large variances in how things would work. And even without that, I'd have literally the same exact phone, but from different carriers would come with different bloatware, predefined installed phone, the application that you couldn't uninstall, and we were getting different results. And how come I had this application installed and it wasn't producing the same updates? And it was just, it's very difficult as opposed to an iOS where you have one and they're going to be exactly the same, and you don't have nearly as many variables. Any questions?
Can you explain a little more what WebView does?
WebView is essentially an embedded browser inside of the application. So if I want a lot of things, I know Wells Fargo, some of these apps really don't look like apps, they really look like their websites. They really are, some of them, the websites, that they're really just internal because, I don't know why they do it that way, if they too lazy or they think it's more secure, but some of them are actually just embedded websites that just go to the application. Maybe it has some additional features that are tied into your application, but in the end of the day, some of them, all they really wanted was to make it that you can have an icon to essentially go to their website, but inside an app.
So how did you use that to support the back end telling the UI that there was something that was shut?
So if I can, so well, that component wasn't in something that Cordova had. So what you can do with a web view is you can inject JavaScript. So in general, if I have a browser, I can just take a new script tag and stick it in there, and I can say alert, hi, and it'll, automatically execute that code as soon as it becomes rendered in the DOM. So the same thing with the embedded web view. As soon as I take whatever SQL I have, which will have in it a function call that I agreed on, and maybe like a number that'll say, this is a scan update telling you regarding a post-install scan or pre-install scan. So I'd say what function it should be called to, and here's the data. And I'd have a certain function where in the front end, I defined a variable that would be able to, and a function that would listen, that essentially it invoked that function when it was brought into the active context. And therefore it invoked in whatever I had as the callback that would be invoked with that data, it would then propagate through the application. So it's fairly simple. Anything else?
Let's see. So yeah, like David said, why do we need your help? You don't have to read this whole slide, but this is from late last year. That's the number of unique device Android permutations. It's almost 12,000. So, and we don't have a full-time team. We don't have full-time QA. How the heck do we know? How does somebody build an Android app and then say, hey, this is stable and it works? And so our notion is to have an internal test plan. So if anybody within CyberPoint who wants to sign up, I've got the ability to add you in and have a copy of the app, and you can try it. And that way we can, we might find big issues with it, but at least the public isn't finding issues. So this is now, we've now the Android 4.4 restriction we've gotten rid of. But generally, if you have a relatively recent Android device, and you're willing to play nicely with this, like I said, we don't have, everybody has a day job, so we're going to have to come up with a agreed upon means, probably Jira, to submit bug reports. So folks who want to play with this, and then no emails, no coming to Jen's office and saying, hey, I have a bug. People can be sort of kind about how we take the ingest of bug reports. Then I think we can go ahead and do this. Unfortunately, it requires your Google Plus account. That's how Android works. I created a private Google Plus community, and if I add you to that, then magically you have access to Melvin all of a sudden. Normally, you won't be able to find it in the Google Play Store. So people who are interested in testing this thing out can just email me, and I'll get you set up. And I think that's about it. And then last thing I wanted to do was demo this for you.
So Mike, that means that the form doesn't have to be rooted?
No, it doesn't have to be rooted. That's a really good point. We're pretty good at being self-critical. Yeah, our app doesn't require having a rooted phone.
Did you run the chain on our app on Melvin itself?
Yeah, it does not. Yeah, I did that.
What if you recognize yourself as malware?
Yeah, that'd be pretty funny.
It's not uncommon.
So this is Melvin running on this is a Nexus 5. It's not like in its startup state. I went ahead and have done some things. The first two things here, you see the auto scan. I just clicked on the top item and the second item. These are auto scans that were done in the background because I installed or updated apps that were already on the phone. This guy down here with the red bug in him, I went to Play Store this morning and said, I'm going to find some sketchy looking Android app. I can't prove it's malware, but I found something that's sort of a hidden phone tracker you put on your kid's phone if they keep losing their phone. And I'm kind of okay with the fact that we flag that as we say that it appears malicious, and I agree. I looked at it and I thought it appeared malicious. I could also do things, since this is a demo, this will probably like crash and blue screen of death.
There's just a lot of apps on there because
yeah, there are.
I installed like hundreds of apps.
Yeah. So you can go through here. You can clear stuff out, or we could pick one.
Auto select does.
Yeah. What is Google Ears? We'll scan Google Ears. There. So that's how fast it took to scan one app, and it thinks Google Ears is okay. You can also tell it to scan all apps. Something that matters. So there's a whole lot we haven't told you today, but what I told the team was like the first requirement is we cannot embarrass CyberPoint. So like that was step A is I think this looks, I like the UI. I think this looks like I would expect a UI to look. Secondly, the second rule was we can't kill people's batteries and use up their data plan. So although this does by default, I'll go into preferences, upload to DarkPoint every sketchy sample it sees, which is really, if we get nothing else out of that, I claim that's a win. If we were to have somehow in the world thousands of Melvins running around and we have our own little feed of Android samples, I'm pretty happy with that. But we can't drain people's batteries and use up their data plans. So by default, we only do that when they're plugged in and on Wi-Fi.
Not only by default. I mean, by default it's checked.
Yeah.
It only happens when it's.
You're right. Yeah, we don't allow them to use up their own data plan supporting this. And if they don't want to give us stuff, they can opt out. And then what you end up with in here is just there's a scrolling history at the bottom, so you can see all the things that have been scanned. And you have the option to uninstall things to remediate it if there's something we don't like. So, questions?
Doesn't always hang out in the upper left corner.
It does when that's interesting. There's notifications. So I'm going to pull down to the notification screen, and that's why Melvin was up in you can't see it because this TV is cutting it off, but in what Android calls their notification bar, we had a little Melvin guy looking at us.
So there's no notification.
So
yeah, it comes up when you have auto scanning in the background to let you know, hey, just like when you see, I don't know if you have Lookout or something, when things are automatically upgrading and uninstalling, it says Melvin scanning, and then it'll let you know, because otherwise you'll have no idea if it scans something that's malicious or not. Because it doesn't, at this point in time, it doesn't do automatically quarantine or anything, but it will let you know right away things have been scanned, and then you can go check, oh, there's a red bug there, that means...
Yes, that was just a notification that it scanned something without you knowing. And I think what it was, I put it on Wi-Fi. I put it onto this hotspot here. It says, oh, I'm on Wi-Fi, and therefore, by default, it automatically feels free to update things. We saw the reinstall happen and scanned it as it was being installed.
I ask a corollary question. I have a couple different Android security apps, and they kind of stay resident in the notification area. It's not virtually all the time. I use Avast and Malware Bytes. I thought what Ryan was asking is this always going to be up there even when you clear apps? Basically, it stays resident, or clear messages rather, or notifications, it stays resident.
You want that? Like,
I'm just asking.
So
no, it doesn't. No, it goes away.
Yeah. You mean the notification icon goes away, but the intent, we're still registered to handle the...
Yeah, I mean, some of these apps have like, always keep the icon in there for quick access. We're not doing that.
Yeah, so you can't see now, but it's gone up there now.
You're what?
I'm on your side of that.
Well, some of the app, they give it as an option, but yeah.
So I could hit scan all apps, so that'd be boring. We'll just sit here and I guess I'll do it.
Not that.
We need more pizza.
How do you pay the phone to?
Oh, I brought in one of my personal Chromecasts, and Android 4.4 and up supports screencast. And then I'm ricocheting the Chromecast off this hotspot. I thought, yeah. So you see, right now, this is funny seeing these updates. This is all the stuff that David was telling you about is happening between the web view and
because otherwise I'd be constantly polling, and it's just not the way it should be done.
Any more questions?
Is CyberPoint the developer name that sits underneath the app in the store?
That's a fantastic question. It's like you can see our colors are there. In the Play Store, the Play Store probably needs a bit more editing, but right now, yeah, CyberPoint is in there. There is an email address like Melvin at CyberPoint anybody who beta tests this thing will see the Play Store entry, what comes up there. But that's part of what we would have to review is how do we like what's being presented on the Play Store. But currently, the main thing is it's got our theme and our pictures, but we have not yet done the one CyberPoint of Melvin yet. You know, maybe he needs a CyberPoint T-shirt or something. Yeah.
Does clicking the install button uninstall it?
When it can, you have some that are built in.
Yeah, but you would click on the artifact itself, like there, check, then you can uninstall it. That's just a label, so it'll tell you different statuses. For instance, if you click on the installed one, you just added a second round.
Yeah, it's being slow.
Yeah, because it's scanning.
There we
So
go.
now you can.
Yeah, it's being
Don't
updated. It's
click
being
it twice.
overwritten.
Right, so you can uninstall it if you see like there are 3 buttons there. There's one for uninstall. I think there's one for remove, and there's one for install. Remove is uninstall and delete, which you can't. And some of them are obviously active, and some of them are disabled, depending on what's selected and depending on what's allowed. So yeah.
I think the auto updates.
But so install changes to different things. Like it'll say uninstalled, or it'll say system app. You know, like those are status symbols. Really.
And aside from that big tracking the case phone app that you talked about, have you found any new malicious apps for this product?
Well, we don't have anybody doing the RE, so we currently lack the ability to prove, is this really malicious? But like I took a brand new HTC phone and 270 apps were on it, and the 2 that we flagged, one was like Weibo, I guess. The other one was like an HTC usage tracking app. And like I say, I'm kind of okay with, you know, I mean, at some point it's like, what is malicious? I believe both of those are probably gathering information about you. So but yeah, that's probably the part that we're, from like the math, science perspective, most interested in, is how, like, worry about accuracy.
From a usability standpoint, for the built-in apps, like that the built-in app is getting flagged, will likely generate support problems, and you might imagine we're going to whitelist all of the built-in apps, because otherwise 1,000 people are going to install this app on their phones, and the built-in apps are going to be flagged, and they won't be able to remove them, and they're going to call us, and they're going to be like, why is this malware on my phone?
Yeah, it's true. That's one of many options. So we put a lock next to them right now and say, hey, we think it's bad, but we can't help you with it.
But realize when you do scan all apps, that omits any system apps. So the only way that you'd ever do that is if you go, and even when you go to select apps, there's 3 options. There's clear, there's auto select, and then there's all. If you do the auto, so if you explicitly do it, and then you'll see the lock. I hear what you're saying, but I think it's kind of like you asked for it, because it'll say system app on it. So,
but the UI stuff, like
right,
if
that was
sorry. No, but that's one of the tough things I think we're going to be faced with is if and when CyberPoint publicly releases an Android app, like the UI, getting the UI good enough is hugely hard. There's so many, like this is several, like I'm super happy within the company. What you're seeing is several iterations between the design group and labs, probably at 3, 4, 5. It was multiple iterations. They were able to come back with CSS and with style changes, with graphics. We were able to go back. They were able to say, why are you doing this? Can't you give the user the ability to do this? Like, I believe the fact that we can stop the scan, I think that might have been an example of something that, like, you have to let the user stop the scan, but you could probably iterate forever on this stuff.
And I want to add that Melvin used to have a tongue that would come out and retract. That was part of our iterations there.
One other question, have you done any benchmarking against other leading malware detection, Android malware detection?
We have the data that Reva showed earlier with how well our detection was working based upon industry average, but no,
that was in general the AV industry average, not specific to mobile or Android.
No, like I say, the goal wasn't, hey, we want to like enter the mobile market and have the best, most complete thing out there. It was sort of how do we get our foot and see where can we do this or not. So there's a lot of wins here. Like I say, the collaboration with the design group's been amazing. This was some math research Reva did based upon some stuff from a talk we brought back a year ago. The math looked good. Dava was able to step in with what he knew, and now here you are looking at an Android app that sort of represents some stuff that CyberPoint knows how to do. So there's a lot of wins here. Go ahead, Ryan.
So if I'm about to sideload an APK, can I scan an individual file before I do it?
It will actually force it will suggest that you do that. If you click on it to install it after you've sideloaded it will give you the choice of opening it either with the installer or with Melvin.
Well, that's only because it's registered. It automatically does it for anything that is registered with an intent.
When you're given that choice, for most things in Android, you get 2 selections at the bottom. Just once or always. If I click always,
then
did I screw up?
No, then you can remove it from there. You can then say, what are you saying? Did you screw up? You said?
If I hit always, can I fix that to change?
Yeah, that's an Android setting. You can change like the default, what the default is. But the idea is, we also offer the option that after you scan it, Then we have an install option that you can then click it and install it, as well as when you uninstall. The only thing is, because if we were rooted, maybe it would be different, but you still have to do the system install and the system uninstall. So if we click the button to uninstall, it'll then still ask you, do you want to uninstall? I think it does it twice now or once?
There's the prompt from us and the prompt from the OS.
Right, so it asks first, like our thing is, do you want to install? And then like the Android one, because you can't, they won't let us just uninstall it for you. Same thing with the install. So afterwards, we let you click the button to install it, but we can't install it for you.
But the main answer to your question was, so if you open it with Melvin, after it has done the scan, it will prompt you to install it, especially if we don't think it's malicious.
But if you want to get rid of the always thing, there's a place to do that.
Yeah.
I can find it.
You can fix that setting on your phone.
It will depend on the brand.
I mean, how would you defeat Melvin was the question. We don't know that we're winning yet, right?
Well,
so
I think it's easier to create a false positive than a false negative.
yeah.
But the truth is that because of the nature of what the feature vector was and what we were using, I mean, they were just random bunch. I mean, as Riva said, there were different permissions that we were using based off the manifest, and there was not any single ones together, but a bunch of. I mean, you would think that some of them are logical if it wants to have write access to external storage or internet, and some of them may have been there and some of them not. So if you knew exactly which things we were testing on and you found a way of making malware on the other ones, that would probably do it. But, you know.
So here's one more example I'll give you as to why we need your help. This is an $80 blue phone, unlocked, dual SIM, but it's slow. There are like whatever 12,000. Look what the aspect ratio does to our composition. I think the about screen. I only play with this a bit.
It's also the same thing on the.
That wasn't on anyway. So there's it's hard. Like we don't have like a staff of minions of QA people to do these. But this
is the approach really. We're going to try our best to work well on every device, or is it we'll work on Samsung and by Samsung as your.
We'll start by if I could get like 30 people, 40 people in the company running this, and the consensus was to form, hey, this isn't half bad. It worked for most of us. That'd be way different than everybody is like saying this doesn't work. It kills my phone and I can't use. That's what we're trying to get right now. We've got what 4 phones we work with right now, and then a couple other people are helping us out. So I think the next step is to find out how real is this, and is it false positing all over the place. There's so many things we can't do. We don't have the ability to to vet the models hugely.
But it's the same process of doing in general mobile web development. You try to make it go on the smallest screen to the largest screens. I could fix it, but I didn't know it was bugged because I only tested on so many different devices that it would automatically adjust to different. You can do different things and hide different items based off the ratio. And
there must somewhere be a company that's like run your app where they take your internet.
It's so funny you should say. It's so interesting you say. As it happens, we actually took a trip to Apkudo, who's right over here, and they have the ability to do mass UI testing. But again, go back to step 1. We don't have a project team or like fund. This is like
that would require money.
That would require. Well, we would have to know what's the user market for this. I mean, this was about. So I was very careful for this talk. It wasn't like there is a market need and requirement, and we can make $1 billion. It was like, hey, we've got a technology. Can we get it to a point where we've proven it? And I'd say we have. And then all the other questions about how do you make a commercially viable Android app, kind of a different.
So the other thing to consider is that I suspect that most app developers, and when I say most, I mean like the entire set of like app developers, most of that set are probably not testing their app on every different device. The small subset, which is making a ton of money off of their apps, probably are. But
they're probably using each class. They're using different sizes and certain brands.
But like most people aren't doing that, and like I think usually what happens for like most app developers is they have a couple emulators, they run their thing in the emulators, they make sure it works, they test it on their own phone, and they upload it to the App Store. And if there's a problem that a user encounters, they will give them a poor rating in the App Store, and they will say why, and then they will go and fix it, and they will release an update. And like that's how real life app development works.
Yeah, right. Users are for testing.
Just so you know, the emulators
How much could you simulate this in a browser? As far as so I know a lot of this is HTML and CSS. Could you actually take some of that and show that in like Chrome?
You could, but once you have the JavaScript code embedded, because there are things in there for like doing that. But once you have the JavaScript code in there and you are running it not in the Android device, it's going to be like, where are all the things I'm supposed to be talking to? So if you have all the right scripts that it's looking for, there's no way it would know the difference.
It's funny because Chrome itself actually has a way of flipping through all the different devices. And
Yeah, so you can actually
what
test
they look
this.
like.
The coolest thing about it is in 4.4.3, I think, the inspect element or the JavaScript console that you can use, you can actually do that with the embedded application on my mobile device. So I plug this in over USB, and I can literally take from Chrome, and I can actually modify the CSS and things on the running application right here, only in develop mode or debug mode. And that's, if I didn't have that, I don't think we'd be able to do this at all because it would be painstaking. But yeah, but you can do everything there, and here it makes it much easier. But regarding the emulators, they work terribly. The actually Android, I wrote a thing on Confluence because there is an alternative. It's the Android x86, which runs incredibly fast, but the official emulator is not a viable option for anything.
It's ridiculously slow.
Yeah, and this is known once.
I mean, when I do it at home, I'm running the x86 version.
Yeah, and the cool thing about that is it won't give you everything because you can adjust the ratio and all that, but there are some vendor-specific things. For instance, believe it or not, I've read between versions of Samsung devices, they have little vendor-specific tweaks to WebView, and they'll have between like company to company, but even model to model, they'll have variances. So it's those kinds of random things that'll make weird glitches in the UI that you can't account for because especially if you're using a stock ROM.
Cool. Well, I think that wraps up our talk, guys. But thanks for coming.